I am here because people are trying to change what you think and how you relate to the world, and they're directly messing with who and how you trust. They're impacting your sense of belief, and you might have already fallen victim to it and not even known. And I'm happy to admit that I have. I've shared manipulated media in the past, not knowing that it was manipulated. My name is Andrew Jenks, and I run the Azure Media Security team at Microsoft, as David said. I also co-head the Microsoft team on our media provenance initiatives and chair the coalition on content provenance and authenticity. I'm also active in Project Origin, which is focused on malicious news media. Along with my partners from across Microsoft, I've been working in the manipulated media space for about 3 years and the media security space for about a decade. And many of you are familiar with my day job, which is to run the PlayReady DRM ecosystem for Microsoft. So usually we're talking about protected content. Tonight, we're going to talk a little bit about Clear. Tonight, I'm here to talk a little bit about combating manipulated media, more or less focused on media provenance, but we'll take kind of a broad view. This is, like I said, a fairly broad talk. We won't get too into depth, but feel free to ask deep, hard questions if you're interested. I'm happy to answer whatever. We also have plenty of time for Q&A at the end, or just jump in the middle, although I can't see the Teams window anymore. Oh, it's over here. I'm going to put that over there. Maybe I'll see hands. I can't make any promises. Feel free to interrupt me.
Fair warning, Jeremy Brown's going to ask you a bunch of play-ready questions later.
That's cool. I think I remember some of that technology. So by the end of this talk, you'll be able to answer 3 fundamental questions about synthetic media. And those are, what is synthetic media? What are some of the available solutions? And kind of what are the fundamentals of an authentication and provenance solution? Basically, what is it? How can we prevent it? And what are we doing in this space to try and prevent it? And the reason this topic matters is because of headlines like these. So if you read the news, you've seen stuff like this. These headlines are scary and they're all real. I stole all of these from online sources. I used to try and keep this slide updated with the latest deepfake stories or the latest manipulated media stories, but frankly, it's become prevalent enough that I'm unable to do that anymore. But what we're seeing is synthetic media play a role in things like protests and military coups and disease transmission. And so this is a critical and growing problem that we need to solve now. This, however, what just happened? This isn't a new problem. This image was one of the first widely circulated Photoshopped images, and it's from 2001. So we've had a problem with malicious synthetic media or satirical synthetic media for years, and we have examples of photographs that were altered to show something that wasn't what they were taken of, right? Why do we care now? What's changed since 2001? Tools have gotten easier, they're cheaper, they're more widely available. They've also expanded from still images to video over the last 20 years. When this photo was created, a copy of Photoshop cost $20,000 and you had to have a hardware key to use it. It was very tightly restricted and few people had access to it. These days, it costs, I think it's $12.99 a month to sign up for a subscription, and it'll run on any common hardware you have. So deepfakes get all the headlines. But synthetic media isn't just deepfakes, and it's important that we recognize that it can also have positive impacts on people's lives. It's not all bad. The framework we think of this as is there's synthetic media, which is any manipulation of text, audio, images, or video, and this can include beneficial use cases like adding captions for the hearing impaired to a piece of media. We can also have fun with apps like Wombo and generate synthetic media of our friends. Malicious synthetic media is any content that's synthetic and built with intent to harm. So that can include trivial changes to deepfakes, as well, or trivial changes to content, as well as more complicated AI and ML-based content, which is a subcategory we call deepfakes. All right, so They use more advanced techniques to generate better images, but all forms of malicious synthetic media are problematic. And to kind of draw a ring around this, I have these three examples, which are actually fairly common and fairly well known. The problem though isn't just deepfakes. So that drunk Nancy Pelosi video on the left side of your screen is an example of a cheap fake, where the original video was just slowed down a little bit to make it appear that the Speaker of the House was intoxicated. It's a trivial manipulation and it's easy to do. The Mark Zuckerberg video in the middle of your screen is actually a deepfake. His lips were replaced using an AI model, and the audio track was changed to have him say things that he probably wouldn't have said in real life. Although you can't be too sure these days, but probably not. That video, the release of that video, had a material impact on Facebook's stock market price the following day because people truly believed it was him talking and truly believed it was real. Another big problem that we have is that folks simply reuse previously published images, but in a different context. On the right side of your screen, you can see the same picture of the same fire being attributed to 5 separate causes. My favorite is this is showing the Arctic burning. And none of these are what the picture was actually of. These are all basically misleading uses of an image out of context. And some of these scenarios can be just image reuse. Some of them can be intentional manipulation of events or things that happen. We've done that. There we go. So why is this a problem now? Again, it's because of scale and accessibility. Authenticating trusted sources used to be really easy. Nobody faked the New York Times that was delivered to your doorstep. Nobody faked the evening news that you got over your antenna. And when you went to a site that had SSL, you could be pretty sure that you were going to the actual site and you were getting the real content. And you as an end user can use these same strategies today to get a better idea of trusted sources. So if you see something online that doesn't seem reasonable, check with the trusted source, see what they say about it and whether it's being replicated or not. But nobody does that. Today, people get their news from YouTube and Twitter and Facebook. And social networking is the dominant way people consume news by far today. In one study, 10 times as many people viewed a story on Facebook as the original story on BBC. And that's just one story on one network, right? So you can imagine the multiplicative effect here. And on social networks, you don't know that what you're looking at is what was published. There's just no real way to tell, other than the account that has posted it. And in not all cases is that even visible to you. So we leave the problem of detecting fake images and video on social networks and other endpoints to end users. And they are terrible at it. Like, they're really terrible at it. The majority of people don't trust in their own ability to tell if a piece of news is real or fake. Self-reported, they will tell you that they don't know whether something is real or not. And this stat is getting worse, even as the amount of news being consumed from social networks is increasing. We also have a time problem. News is temporary and it doesn't exist very long. Most stories are only relevant for about 72 hours. So if something misleading or false gets out there, something manipulated gets out there, you have a very short time window in which to make any adjustments or make any changes. And people watching media on social networks tend to watch less of the content, ignoring clues that media might be falsified. So all of this adds up to a really big problem for society, for businesses, for democratic processes, for journalism, and literally for you. Real harms are being done in all of these areas. People are losing faith in reporting. They're losing faith in democracy. And they're being exploited in media, and it's being done on the back of media that is falsified, that is made up, that is synthetic. We consider all of this a form of cognitive hacking. That means changing what people believe, even when those people are making very rational trust decisions. So we've put people in a position where they try to do the best they can, but they don't have the tools available to them to make decisions that they think are perfectly rational. And in their shoes, I might be making the same. And it gets even worse. It turns out that when there's a certain amount of disinformation in the world, people believe less true information. That's called the liar's dividend, and it is a fascinating topic that is worth research or a talk on its own. But basically what it boils down to is when anything can be a fake and you can't tell, you can't be sure that anything is true. And I think this is a really powerful concept because it goes to the most important harm of malicious synthetic media, which is that it is directly harming your relationship with reality and your understanding of what is going on around you in the world. So all of that is super bad, right? And we don't like that. So what can we do about it? We can actually do quite a bit of stuff about it, and we have folks have efforts going on in all of these areas. But we can make people smarter about the media they consume. We can institute new policies on platforms to help protect users. And we've seen some recent movement in this from the likes of Twitter and Facebook both. We can pass laws, but we can also develop and deploy technical solutions. And that's kind of what we're going to be focused on for the remainder of today. So when we think about technical solutions, there are really three areas we worry about. Detection is the ability to automatically determine if an image or piece of media you're looking at is real or fake. Authentication is the ability to tell that something came from a trusted source. And provenance is the ability to get additional information about a piece of media that helps you make a more educated trust decision about that media. So the three of these are kind of different approaches to solve a similar problem, and they're not mutually exclusive. We can apply multiple of these techniques. So everyone wants to talk about detection first because it sounds great. Just build me a technology that'll tell me if the thing that I'm looking at is real or fake. Tell me when I'm being lied to so that I know. And this is a super active area of research across multiple large companies. There are lots of techniques that have been developed in just the past few years to try and tell when an image or video has been manipulated. Microsoft research, teams around Microsoft, Facebook, lots of other folks are very active in this space and have done their best to create good detectors. One of those is this thing called Microsoft Video Authenticator. And it was built to detect manipulated video, and it's one of the better detectors in the space. It's being used in newsrooms today to help tell if incoming citizen journalism is real or has been synthesized, and it's a very helpful tool on the floor of newsrooms the world over. So if detection is great, why do anything else? Why not just rely on this? Turns out detection is an arms race, and those of you with DRM experience will be very familiar with arms races and how much fun they are. If you have a good detector and you actually use it and provide it to others, you can create a generative adversarial network, tie that with your synthetic media generator, and train that network to generate media that can't be detected, right? That's not even that hard to do. And today, the best AI detectors we have are only about 60 to 75% capable. That means they miss a quarter of falsified information. And from what we can tell, that success rate actually appears to be going down. If you misidentify a piece of media, and it doesn't matter if you misidentify something synthetic as something real or something real as something synthetic, you get back to that liar's dividend problem, where you can't be sure that what you're looking at is real or is fake. You can't know. So both false negatives and false positives hurt the end user in detection scenarios. So while we're working really hard on making detectors better, and we think it's a useful tool in the toolbox, we don't think it's a panacea. We don't think that it is the answer. And so we need to look at other answers. One of those other answers is authentication and provenance. And we're going to dig into these in quite some detail and talk about how using these in combination with detection can help us filter information and provide better trust signals to users. So what do I mean when I say media provenance? Media provenance provides additional information about a piece of media. That additional information, those pieces of data, can be anything you want, from the title of a work to the full list of edits performed on an image in Photoshop to encrypted data that only your company can read. That data is then bound to the actual piece of media you're describing and authenticated by a signature so you know who added it, who provided that. There can be multiple provenance manifests in a single piece of media, and they can be linked together to provide what we call a chain of trust that can go all the way back to the origin of a piece of media. So think about knowing the history of a piece of media all the way from the point of the camera that actually took it, or perhaps from the point that the BBC published it on their site, and being able to track that information and get that information when you see a piece of media on a social network. So provenance is additive and optional. This doesn't require any new media formats. It importantly works in the clear media space. This just provides a new ability to help end users evaluate media if provenance functionality is present. But we're not breaking the web here, right? The media ecosystem is incredibly diverse and complex, and all of that continues to work with media that has provenance information in it. In practice, what this looks like is provenance data comes with metadata and something that we call a manifest. And that manifest is cryptographically bound to the media asset through hashing of the actual bits of the image or video, and that's signed by the creator of the manifest. So when you validate a manifest, you can be sure that the information in it is what the publisher or the signer put there, and that the actual asset hasn't been edited on its way to your eyes. So you can find out if a piece of media has been changed between the time it was published and the time you're consuming it. A manifest has 4 parts. It most importantly has the fingerprints of the asset itself, again, to bind it to that asset. It has metadata. For this session, maybe I'd include the title, my name, the delivery date, but you can put whatever information is important for your specific situation into here. It's completely extensible. It can, but doesn't have to, contain the edits you made to a file. So for example, if I was editing an image in Photoshop, I could keep track of all of the edits that I made to demonstrate to people what I did to an image. And finally, it contains a digital signature over all of the data above that allows you to link it back to a certificate or an identity that shows that you're the one vouching for this. The signatory is the one who's saying these things about this piece of media. Whether those things be true or false, there is someone who has taken responsibility for them. So what's kind of important here? This system, as we've envisioned it and designed it and spec'd it, is as strong as well-known cryptographical processes. An end user or user agent has the ability to validate video at consumption time and make sure that it's been unchanged since publication. It can be bound to common media formats. So we've come up with solutions for the formats listed in the top right here, but frankly, this is applicable widely to digital assets, and you could easily bind this to multiple other formats. And it works in the clear media space, so it doesn't break any of the existing infrastructure that exists today. So all of this is great, and this gives us another tool in our toolbox, another way to provide users information to help them make a trust decision on content. But you might be asking yourself, if you have PKI experience, why is this hard, right? Just sign the video, be done with it, add a manifest, sign the entire thing, call it a day. And that's a really good question. So let's talk a little bit about why this is complicated. And this might be old hat for this audience, but I'll go through it quickly anyways. I normally warn people that this is when we get into the guts of how media actually works, and it can be a terrifying space. But I think for this group, this will be very common information. So a video on the web isn't one video. YouTube provides a great example of this. If you upload a video to YouTube, what it actually does is transcode that thing into multiple different formats. Generates 16 separate video-only streams, 2 audio-only streams, and 3 streams that have audio and video mixed together. So one upload to a social network isn't one upload. But if we know that we're generating all these things, could we just sign these generated things and be done with it and be back to a very easy, simple solution? No, because one video isn't one thing when you download it either. Because of things like adaptive bitrate streaming, clients can dynamically switch streams and even dynamically switch codecs to optimize the viewing experience. So provenance manifests are designed to support adaptive bitrate streaming and handle this problem of videos being transcoded and then streamed down in chunks. And we do that through this method we call facsimiles. So when different media assets are being created from one thing, and then different assets are being played back, provenance manifests support these by allowing you to declare facsimiles, things that you're saying are effectively identical representations of a piece of content. And then you hash individual chunks for each of those facsimiles, and you store those chunk hashes in a manifest. So this architecture allows clients to easily authenticate any facsimile, regardless of which one they're looking at, that the user wants to play quickly and with minimal download of extraneous information. So I don't have to do things like break progressive download in order for this to work. I can validate pieces of a file. I can validate chunks in a streaming scenario, or I can validate entire files if that's my scenario. Media can also undergo legitimate or illegitimate transformations, where a manifest of the transformed media is lost. This might happen if an editing tool doesn't know about provenance and simply strips out the manifest box. It might also happen in attack scenarios where I don't want you to know that there was provenance information in a video that I'm editing. I don't want you to know that it has been edited and I intentionally removed the information. So we're exploring the use of both soft bindings and watermarks that can be recovered by the media player and provide a hash of the original media object and or a URI that corresponds to a service that you can imagine is hosted by a publisher, which can alternatively be used to authenticate the media and provide what we think of as candidate manifests, manifests that might match and that you might want to evaluate. This helps when you're bringing up a brand new ecosystem where literally none of the tools support this yet, because it allows media to still flow, manifests to still be created, and those to be recoverable by the end user, even if tools don't support this yet. It also helps, like I said, in cases where people are intentionally stripping manifests to try and pass off malicious works. How am I doing on time here? Oh, we're good. So let's talk a little bit about the industry organizations, the various groups of people who are doing active work in the authentication and provenance space today. There's really 3 centers of gravity around provenance today. Those 3 bodies are Project Origin, a group called the Content Authenticity Initiative, and the Coalition for Content Provenance and Authentication. So Project Origin was formed by Microsoft, the BBC, New York Times, and CBC a few years ago, specifically to evaluate technical solutions for the rise of misinformation, malinformation, disinformation in news media environments. So the question that was posed was, is there a way to do something about deepfakes? And they got to provenance from that point. They were focused on provenance from the point of production. Think of it as publication by a news entity to the end user consumption point. So how do you make sure that pathway is secure and what the end user thinks came from the New York Times actually came from the New York Times? But at the same time that was going on, Adobe started something called the Content Authenticity Initiative, which is targeted at creatives and particularly was looking at solving the same problem for still images instead of for video. And they were really focused on solving the provenance problem from the point of capture to the point of production. So it's exactly the same problem. It's a slightly different problem space. So when you think about it, these two problem spaces combined covered scenarios related to provenance in media all the way from the point of capture to the end user. And these groups found each other and got together and said, you know what? We need an interoperable solution here. We need something that works for the ecosystem. We shouldn't standardize this stuff twice. We shouldn't build two different solutions to do the same thing. And so they were the core members that founded the Coalition for Content Provenance and Authenticity. And that single interoperable solution